put the flag in Portugal when you talk ocean technologies. This is time to start a new age from explore the sea. Okay, the times of 2D is not more possible to continue. We need to go and work in 3D or 4D because the time is also important, and we need to explore in above the water, surface of the water, and underwater, and in the seabed floor. Okay, this is we need to learn this technology, we need to develop, and we hope this project can do this, help us to do this. Without the partners, without the other people, it's not possible to do this alone. And Diana, please go to today to start explain the methodology of the project, and go to show us beautiful ideas for that. I hope the people enjoy, and thank you.
Okay, good morning all. So I will present a little bit of, the basics of what we expect to be the implementation of the project. So I think you all have seen this image yesterday. Is a quite complex image, but it resumes quite well what we aim for in INESCTEC.OCEAN and what we expect the new center of excellence pillars would be. So we have divided all the growth of the Center of Excellence in 4 major pillars: the governance, the excellency, the business partnerships, and the infrastructures. So moving on to excellency, this is a center of excellence. So the idea is to somehow create brainware, increase the knowledge in ocean engineering. And to do that, we need to somehow increase our research capacity, and we should also take into account the academia and somehow try to move forward with new advanced courses, with new knowledge in ocean engineering related areas. So what we expect to build is to get memorandum of understanding with academia, to work with academia to get better prepared people to address this type of topics. We want to have doctoral programs, we want to have master programs, postdoctoral programs related with these areas. So we need to work step by step with academia, with universities. INESCTEC is not academia, so it's a research institute. We want to give tools to academia to rise up the knowledge in these topics. And we want also to get better scientific strengths and also better link with industry. As José Mendonça mentioned yesterday, so we want to grow with all the stakeholders. We want to understand their needs, their challenges. That's why we promote yesterday the stakeholder forum, because we want to understand what are the challenges in the different markets to try to address them. So we need to get a better close connection with industry and try to engage industry in the creation of shares. And also we will have during the project, because this is not a research project, although the European Commission funds a small amount of the budget for an R&D project, we want to build with SINTEF a project, R&I project, in order to engage both institutions and all the consortium in one specific topic, scientific topic. So the excellency will be something like this, and in the time span of the project, so this is a 6-year project, and then moving on, of course. We have divided in 2 years of setting up, 2 years of consolidation, and 2 years of sustainability. We will have the administrative and financial autonomy after year 4. We need internally to understand what are the features that this new Center of Excellence must have internally and with the consortium. So that's why we put there administrative and financial autonomy at year 4. And we want, so this is a possible timeline of what we expect in terms of excellency. And you can see that we have divided education and training and R&D because they need to move side by side to improve the overall excellency. So master and the PhD programs, the Memorandum of Understanding with academia, we really want to somehow try to build up specific courses or advanced courses in these specific topics of ocean engineering, then internships or hands-on summer schools and demonstration to put students and people with hands-on, with real scenarios and demonstrations. The corporate shares, where we want to have a close connection with industry in order to understand, and they can sponsor someone to work in close connection with academia and with INESCTEC.OCEAN, and the joint R&I project that I've mentioned. Moving forward to other dimension, other pillar, the business partnership. As we mentioned, it's very important we need to grow together with all the stakeholders, not only industry, but also policymakers. We want to understand what are the challenges, as we mentioned. So we need to promote this type of connection to somehow increase the ecosystem and the awareness on this topic. And in which concerns to Portugal, we are ocean. So we are facing the ocean, we have a huge amount of coast, we really have a huge potential and we need to grow in that direction. We are the door for Europe, for the Atlantic. So this is not only strategic in terms of a national level, but also at European level. And we want, in fact, to engage all the stakeholders to help us to build up this Center of Excellence in the right direction. So we want to establish partnership with the quadruplex ecosystem, so civil society, policymakers, academia, and business. Cross-fertilization initiatives with SINTEF as our advanced partner, it's very important to have that. Innovation project development, so we want, again, to have a close connection with industry and try to face their own challenges with specific topics that they find important for their market. Industry-affiliated programs, so we want to establish a long-term protocol with industry so that we can both benefit. We benefit from their knowledge in terms of the overall market and the challenges, and they benefit from us with our scientific knowledge, brainware, and also infrastructure for testing new prototypes. And of course, the IP, different type of IP initiatives that could come. Again, with the same timeline, we have different types of initiatives. I cannot read, sorry. The contract is not very good. But so again, it's a little bit what we have resumed in the last slide. So of course, all these initiatives should come not from the first moment. This is something that needs to grow during the project, but we want to set different type of events and initiatives along the 6 years project in order to have, in fact, a close connection with industry. One of them, for instance, is the stakeholder forum that we have done yesterday. And if you recall our areas, so we have 4 main scientific areas: energy, robotics, data, and structures, marine structures. And yesterday we had 2 panels in the stakeholder forum, one related with data and the other related with energy. So we want to continue this type of events, to putting all the players together. Then the infrastructures. So it's very important that, in fact, we can take advantage of our infrastructures and we could update them in order to face the challenges that we might have in terms of science. It's very important. We have a very broad TRL level with our competences, but since that we are going to work very close to industry, we need to have ways to test ITRL levels, technology and scientific developments. So the idea is to establish protocols with existing infrastructure. We have already Tech4C infrastructure. We are the coordinator of Basel de Leixões, that is the ocean basin that will finish the construction in the end of this year. We are also the main shareholder of Companhia de Energia Oceânica, that holds a test site in Axadora for offshore technology. So we want to establish protocols with these infrastructures that already exist. We want to define a roadmap for infrastructure. We want to update them, and we want to get new equipment to face the challenges, the future challenges. Again, the same timeline regarding the distribution of this. So we expect that we might have the first protocol with already existing infrastructures after the first year. So we need to start working now. And we will try to improve our laboratories and our infrastructures along the years till the end of the project. Then the governance. It's a very important pillar too, because in the end we will have a new center of excellence with financial and administrative autonomy. So we need to understand what will be the governance of this new institute. What would be the intellectual property policy, and what would be the future management and the future funding strategies. We need to understand what would be the sustainability of this center. So everything needs to be addressed. We need to start now, and we want to understand also with Sintef-Ocean what is their model, and try to understand if it is or not feasible to adapt this model to this new center of excellence. So we need to build up. It's very important that you all understand that we have received a 6-year project funding, but we have a center that we will create. So we need to somehow understand what would be the future years after this funding and how it will be sustainable. With the timeline, so there are a lot of activities for the first year, the contracting policy, the creation of executive committee, the definition of the scientific coordination centers that will be the heads of the 4 different areas, and also the science definition, what we expect in the long term of the project. So these are all expectations, so it's it's not written on stone, but it's what we aim to. And as you can see, so in the final of year 4, we have a set of milestones, because since we will reach the administrative and the financial autonomy, we need to have a lot of things set, so a lot of milestones there. So considering this and taking in mind all this rationale, we have divided the project in 7 major work package, but you can clearly see that it's one for governance, one for the pillar of governance, one for the pillar of business, one for infrastructures, and then, since we want to build a center of excellency, we have 2 work packages dedicated for excellency, because we think this is very important and we need to take care, and with deep knowledge, we want to address the R&D and the education and training. And of course, we have the project management and the communication work package that we have called visibility and outreach, because it's more than a standard communication work package, so it's more. And well, this is very boring, so it's a Gantt chart. It's just for you to have an overview of what we expect to have along the years. So all the work package will run the 6 years, but different tasks appear in different moments of the project. So work package 2 is the one related with governance, with a set of tasks on it. Then we have the work package 3 and 4 that are related with excellency, and the work package 5 that is related with business. And as you can see in the business, some of them, the tasks are more towards the end of the project, because we need to establish first the links with the industry and then move forward. And the infrastructures, of course. And I think that's all. Since this is a very deep, I think, and complex information, I'm open to questions. Thank you. Anyone? All clear. Okay. So we should move forward to the next presentation. Luís Seca will present our technical infrastructures.
So, good morning, everyone. Perhaps, Diana, they had not enough rest after the long and fruitful day we had yesterday. My name is Luís Seca. I'm a researcher at INESCTEC in the power and energy domain. I'm also a member of the board of directors with the responsibilities of the overall infrastructures of the organization. Today we will be focusing in the next minutes on some technical infrastructure that we believe that are critical for the implementation of INESCTEC.OCEAN. I will present them in 3 different parts as parts of a puzzle that in the end you will understand how they can collide in an overall response that we consider adequate for the challenges that INESCTEC.OCEAN brings. And so the first point is, how critical can these infrastructures be for us to achieve our objectives? Not only for fundamental research, but also for technological condition to validate many of the developments that we are envisaging in the project. And so the first piece of the puzzle is our Tech4C infrastructure that is part of the National Roadmap of Research Infrastructures from FCT, so is a recognized infrastructure that has a set of innovation services that, as you can see, are multidisciplinary. So we have they are spread, or the infrastructure is spread in a number of laboratories. Some of them you will be able to visit, the next one after this session. But here you can see that from optical and biosensors to communications to data management to this offshore renewable energy sources, energy vector integrations, digital twins, perception, underwater position. So it's an infrastructure that has a comprehensive set of tools that allow us to respond to the challenges that the ocean poses us. The first one, that is the one that you are going to visit, is more related to our research group on robotics. We have over 1,000 square meters of lab space, so it's a significant space for our researchers to develop the solutions, 2 test tanks, a hyperbaric chamber, and many solutions for CNC and 3D printing, so we have the capability to produce different prototypes and pieces for the prototypes. This is probably where everything began. You have some pictures on the side, but you will be able to see them. Let's hope the weather cooperates and will not get wet when we go there. Then, of course, what we have, somehow the most differentiated solution that we have, that is Mar Profundo, the research vessel, a catamaran that is very flexible and that allows us to operate in quite significant distances already. It's a vessel that has the capacity to take researchers and to support this activity at sea. It has been very recently improved, so we are now able to go further. And we also have invested in a dynamic position system that allows the vessel to be stable and to provide the support to research activities. But it's not only the sea, it's the vessel is the vessel and all the other infrastructures that allow us to place the robots in different areas to have support for the treatment of everything that is collected offshore. But of course, being one very important part, here I would just like to highlight the different missions where the vessel has already provided support in Portugal. So it has been an infrastructure that was a stepstone, I would say, for us in this area, because it allows us to be present in different occasions and in different missions to be able to mature our capacity overall. Of course, it's always growing with other solutions and other assets, but this is something that is, let's say, the base infrastructure that allow us to start developing the solutions for sea. The next one is Azul Leixões. It was also mentioned here several times. We believe that this is critical for us to move one step forward. It's a project, it is ongoing. We are now in the process of the public tender to start the development of the building. 3 main vectors: decarbonization and energy efficiency, digital transformation, and circular economy. The idea is that we are capable to foster alternative solutions in other areas, as you will see. It's a consortium, so it's not something that is belonging to INESCTEC, is coordinated by INESCTEC, but it necessarily involves other institutions, because we believe that, again, the only way for us to accelerate the sustainable and friendly transition is to involve other actors. And here we have 2 main, let's say, distinctive characteristics: the ocean basin that will make up for the lack of these testing areas in ocean technology that we have in the country, and at the same time allow us to test and validate both on the renewable energy platforms, robotics and sensors, to be able to test the different prototypes and collect data. Of course, it has at one single point one diving well at around 30 meters that also will support the training of people with diving skills. and includes the implementation of CIMAR, also a partner of the infrastructure, of a blue biobank at the cruise terminal that is entirely dedicated to the mapping and managing access to various marine resources. So, in a nutshell, it will provide the testing capacities, the scientific diving centers, the biobank and blue technology laboratory, and also some additive manufacturing laboratory for marine environment. So I would say it's one step higher than the one that you saw in the first place, not only in terms of depth, but in terms of size and in terms of tools that we'll be able to include. As I mentioned, it's a set of relevant partners, because being multidisciplinary, we were all put together within the same objective. The third piece of the puzzle is something that we decided to invest around 2 years now. That is Companhia de Energia Oceânica. This was a company that initially is on site. It's a site that is placed in Aguçadora, in Póvoa de Varzim. It was very relevant to support some of the technologies that were tested in Portugal. And we decided together with WAVEC and EDP to make the acquisition of the company, to try to transform it into something completely different than it was so far. That is, we want it to be a test site for marine technologies in an earlier stage. So it's a site that was there to support some of the most recent developments a few years ago, but the purpose was to sell electricity on shore. It has quite a reduced capacity, around 4 megawatts. Considering the development over the last years, we strongly believe that this infrastructure will be an enabler for the development of many of the solutions that we are envisaging here. Why? Not only because, as you can see, it has created the conditions for different technologies, from AWS to the famous Pelamis and the first tests of the wind float Atlantic that now is in Viana do Castelo. Because it has a very specific condition. You can see the average wave energy that you can get in Aguçadora makes it one of the harshest test sites that you can find in Europe. So it's very critical, because, as we discussed a few months ago with Core Power Ocean, if something survives to Aguçadora, it will survive every other place that you have in Europe. And so we had the demonstration from the solution from Core Power Ocean. The main advantage is, as you'll be able to see, it's a substation that is at the beach, right on top of the dune. So it's something that is very unusual. I would doubt that today we would be able to have a substation in that place. But it's very flexible. So, for example, the solution from Core Power, they tested every time they needed to remove it for additional testing or development. It was easy. So it's something that promotes the real test site condition in a very harsh environment, with scale prototypes, as we saw with Core Power. We already have other partners, such as Gazelle, that we are studying how they will be able to make their own testing. What is important here to say, in terms of overall conditions, it's a substation that connects directly to medium voltage. We have a 4 megawatt transformer, but we have a SCADA system. We have now 2 cables, one that is under operation that is related with the tests of Core Power, around 3.2 megawatts, but we have the old subsea cable that is also a very important asset for us to develop and validate some of the developments that we have, for instance, in the autonomous robotics, because it's something that will allow the robots and the people to understand where the cable is damaged and to test different solutions that we have. Our intention here, and this is something that is very important, is to change a little bit the dynamic of the site, and we want to reserve this area for a technological-free zone, as we call it, because the idea is that we can develop a hub where we can test different technologies at the same time using the same resources. We have communications, we have sensors, we have SCADA systems. The facilities allow people to sleep there, to stay there, to take all the data. So it's something that we believe will be also a very important lever for marine technologies. These are some of the main services. It's an extensive list, but the main idea is that it will allow this multidisciplinary evaluation of the impacts of marine technology. So not only from the power system perspective, but also from the asset inspection, also in terms of environmental impact, always bearing in mind that companies that are exploring this sort of technology usually have some difficulties in making real testing available. And so our focus here is that we can create a condition where very easily every technological partner is able to test these solutions in the different vectors that you can see here. So all the multidisciplinarity that I brought from the beginning in terms of communication, data collection, and so on, it's also something that will be available here. It will be a relevant actor because in terms of offshore renewables, and particularly in Portugal, there is a clear idea that there is a lot of resource. The former government had a very ambitious objective of 10 gigawatts of offshore wind. Now it has been reduced up to 2. The northern region of Portugal is where we believe that the first implementations will appear. And so, again, the test site is very relevant to be able to validate alternatives in terms of offshore wind. Because of the nature of our coast, they always have to be floating infrastructure, so different alternatives that can be provided can be tested there. But as you can see, it's clearly an area where Portugal has a lot of resource, and we intend to be a very active player in this area. To close up, the 3 pieces of the puzzle. So it all makes sense when it's put all together. So not only to support the fundamental research, but also to allow us to test in real conditions these 3 infrastructures, together with others, because some of the assets that you see in Tech4C are spread in many other laboratories that we have, from power energy and energy to communications to photonics and nanomaterials. But the idea is that these 3 infrastructures will be at the service of INESCTEC.OCEAN as a support for the implementation of the project. And this was what I had to bring you today. I don't know if there is any question. We're fine. Thanks.
And I suppose you start to go to the lab.
Let me explain. Let me explain the logistics behind. So we will have now a visit to our labs, the robotic laboratory. Some of you already know, but I think there is always something new to see. So I will ask you, there will be 3 persons that will be guides to you. So Bettina, that is over there, Paula, and myself. So I would like to ask you to divide it in groups of 20, more or less. So Bettina, perhaps you can just start, and Paula. So as soon as you have 20, you just go. Okay. And we will visit the lab, and then after the visit the lab, the coffee break will be at 10:30. So just 20 and go, and then you wait for Bettina. And the last ones will go with me. You can leave your backpacks and jackets here. The auditorium will be closed, and we'll come back here after the coffee break.
PhD thesis, Sophia and Ines. Sophia will work in hybrid energy storage solutions for these farms, including several energy vectors. Ines is working on the layout optimization. We have already some journal papers and some conference papers. So this is a work in progress and will end hopefully in August this year. We are also working in non-electrons area, meaning in energy, but in data. So we have this INESCTEC project in cooperation with CEL, the company of Energias Oceânicas, and we are collecting data, we are organizing data, we are putting data for the service of now a very good trend, artificial intelligence, so that this data can be used by several stakeholders to understand if the farm is working properly, if the resource, or to forecast the resource, I would say, to make the so-called digital twin of the farm. So this is an ongoing project also, which we are working on in the area of the offshore. Coming closer to shore, we have also the Magpie project. It is a project for green ports, also funded in the framework of the Green Deal. And here we are trying to make those ports the greener as possible. So we are working on renewable integration. We are working on several energy vectors. We are exploiting the hydrogen. We are understanding how we can make the ports more eco-friendly. Perhaps I'm going too fast. If you have any question, we will have some time at the end. And here we had recently a consultancy experience together with the Portuguese Association for Renewable Energies, which was understand, as you know, Portugal have now ambitious plans to interconnect offshore wind in Portugal. We will have soon a tender for that. And we need to understand how our grid will behave to accommodate this amount of new energy. And perhaps it will need to have some investment, some expansion. So here we deal with that. So we made studies, several set of studies, to understand what could be the potential problems that could exist on the grid and propose some solutions so that we can accommodate the amount of energy that we are expecting to come. Of course, this is everything is very made based on scenarios. Our government, for instance, at the beginning thought about 10 gigawatt of offshore power. Now they changed to 2. So the solutions are not the same for the amount of power we are talking about, but we made a kind of scenarization, and we have at least a good idea on what kind of investments must be performed on the grid. So, to briefly finalize my presentation, I bring also to you, and we will have possibility to discuss this in more detail, I hope, some research lines, some things for the future. So, things that we believe that could be interesting in terms of offshore and could be interesting in terms of this INESCTEC.OCEAN initiative. The first one is evaluate how offshore combinations and hydrogen combinations could be beneficial. What businesses it could leverage, what are the costs involved. So, in our opinion, this is one of the topics. Another one is the layout optimization, considering multi-physics, not only talking about the layout itself in terms of cabling, but also taking into account other disciplines such as understanding the anchoring, the mooring, and how this multi-technology, together with this multi-physics approach, will interfere and will shape the final layout. Another important aspect is the energy management of these farms. Different solutions, different combinations will bring different management approaches. And of course here the existence of storage may shape things, and we would like to work on that. How these farms can be grid friends, and by grid friends I foresee scenarios with a massive amount of offshore wind, not only wind, but offshore energy integration, and we will need support from these assets to help the grids. And Black Start is an important aspect. If we have a major problem in the grid, how these assets can support the Black Start strategies to onshore grid. Also, more in a technological way, we would like to research how we can have compact substations. Is it better to have it floating underwater? What would we need inside those substations? What size they will have? Those kind of things are more technological, but for us it's very important to study. Digital twins are in the agenda also. Try to make the most accurate digital twin of offshore farms. And in terms of ports, how can we increase the renewable integration and associate it with hydrogen to have the ambition target of 100% of renewable energy sources in ports. So, basically, this was my presentation. Any questions? Any remark? I was clear? Perhaps too clear and too fast? Okay. Anyway, you have my contact here. We will have a chance to talk in the afternoon and tomorrow. So please try to reach me. Thank you very much.
Okay. So I was tasked today to present almost an impossible mission to present these slides within the time span of 50 minutes. So to keep it on time and focused, I wrote, and I will try to follow it through my guides. So our focus is on advancing technologies and methodologies in three complementary research lines. Sensing is the backbone of understanding marine ecosystems and mitigating human impacts. Advanced sensors help us monitor environmental changes, ensure sustainable exploitation, and protect marine habitats. Communications are vital for IoT and data sharing across ocean environments, addressing challenges in data transmission both at underwater and above water environments. Digital twins technologies offer a transformative approach to modeling and understanding ocean systems. And in this line, we explore human-AI symbiosis, data processing for hybrid digital twins, and immersive visualization techniques. Several initiatives demonstrate our background in each of these R&D lines, but due to time constraints, we have selected just a few to showcase it. In the INAQUA project, INESCTEC is developing tools to enable the capture, storage, and processing of sensor data. It is achieved by developing innovative optical sensors which, combined with commercially available devices, will form a multi-sensing module that adds significant value to advanced control systems. We are also building digital twin backbone to streamline the ingestion, transformation, and storage of sensor data, ensuring data accessibility in near real time. In the Submerged project, INESCTEC is extending existing submarine cables with new purposes. These cables, which are already employed by the research and education networking community, are being leveraged to monitor Earth systems in a groundbreaking way. This approach not only improves the efficiency of these systems, but also enhances the return on investment by broadening the use of already installed equipment with impactful solutions. In the Resilient Recovery Project 8, key focus is the development of a comprehensive digital twin to analyze and simulate the construction and operational phases in a floating offshore platform. INESCTEC is responsible for designing innovative sensor systems to monitor critical aspects during and after the platform's deployment, such as embedded optical systems for real-time monitoring of the concrete curing process and the watertightness once deployed. Post-deployment, the sensors will also monitor changes in the aquatic environment with optical solutions for tracking water acidification and turbidity. Motivated by the critical and challenging need for precise and durable sensors, our research aims to advance ocean monitoring and to address existing sensor limitations by both enhancing ocean monitoring sensors' reliability, sustainability, and efficiency, and creating scalable and cost-effective sensor networks capable of real-time data sharing and interoperability. There are 4 topics in this R&D line. In the line of optical sensors for structural monitoring, we aim to explore further our results with microfabrication and chemical manipulation capabilities to design and to develop sensors for real-time data acquisition engineered to withstand extreme conditions, ensuring durability and longevity. Potential applications include monitoring the curing process of reinforced concrete structures to ensure optimal properties, enabling early detection of structural damage to reduce repair costs, and supporting the development of advanced anti-corrosion coatings while monitoring their long-term effectiveness. Regarding biochemical monitoring in aquaculture, our work focused on developing advanced optical solutions to optimize production and enhance sustainability. We design optical-based sensors tailored to specific parameters, leveraging advanced nanofabrication technologies to enhance sensitivity and chemical functionalizations to improve target selectivity. These sensors provide real-time parameters acquisition and are equipped with local processing capabilities for swift response to environmental changes, known as edge computing. They also feature remote monitoring and efficient sensor multiplexing for comprehensive and timely data collection. Our research on spectral imaging technologies aims to advance techniques such as laser-induced breakdown spectrology and Raman stereoscopy, hyperspectral imaging, and machine vision for rapid and efficient characterization of marine environments and infrastructures. The objective is to develop robust methods for real-time spectral characterization, including knowledge transfer algorithms to enhance high-throughput systems with precise data and from LIBS and Raman. In addition, our work involves optimizing optical sensing systems capable of performing in harsh environments to create a cooperative sensor ecosystem, overcoming individual limitations and expanding detection capabilities. Regarding distributing senses, it focuses on leveraging advanced techniques for distributed acoustic sensing and state polarization. These methods detect nanometer-level changes in fiber optic cables, enabling the identification of mechanical disturbance along the fiber. These cutting-edge technologies facilitate real-time monitoring, supporting the tracking of marine activity, the detection of geological events, and the enhancement of security and surveillance. The next 2 slides show our background on marine communications. In the BlueCom project, we developed a novel solution to extend coverage from shore to remote maritime areas. The solution was based on the use of passive unmanned autonomous vehicles, the balloons, acting as high-altitude base stations and forming a multi-hop network, providing coverage for humans and machines using standard wireless access technologies like, for instance, Wi-Fi. The solution was demonstrated in a real-world environment in Sesimbra, where we were able to communicate at speeds up to 1.5 megabits at a distance of approximately 50 kilometers from shore. In the GROW project, we have developed a novel underwater communication solution using a data multiplexing approach that combines the use of short-range optical and radio communications with acoustic communications to control the operations in the data mules. This provides delay-tolerant, long-range broadband communications that exceed the performance of state-of-the-art acoustic communications. From our past experience and motivated by the growing presence of IoT devices, autonomous vehicles, and humans in marine environments, we aim to address the challenge of providing reliable, high-speed, and affordable communications at surface and underwater. To overcome this challenge, we envision an innovative approach to improve reliability, quality of service, and sustainability, and to revolutionize how data is transmitted wirelessly. In the underwater environment, overcoming latency and reliability challenges are critical. We're exploring semantic communications, transmitting the meaning, not the raw data, Gen AI and Edge AI to move beyond traditional methods, ensuring efficient data transmission through acoustics, optical, and radio technologies. Similar advancements are being applied to enhance communications above water. By leveraging cutting-edge wireless technology, we aim to address reliability, latency, and bitrate limitations. The four next slides highlight recent works towards hybrid digital twins of the ocean. In the XCAP project, we explored the application of expert crowdsourcing in climate and climate change research. By engaging experts to annotate atmospheric phenomena, we aim to enhance the semantic understanding of large data sets gathered for monitoring the Earth's vital signs. This approach not only improves data description, analysis, and indexing, but also optimize automated methods and computational resources through a hybrid approach that combines human expertise with advanced algorithms, leading to more reliable and robust results. Digital twin technologies offer a transformative approach to modeling and understanding ocean systems. Projects like Iliad are setting standards and best practices, paving the way for these technologies. The Iliad project, a European flagship project, aims to create a federated architecture of interoperable digital twins. INESCTEC most relevant results include gamification on citizen science demonstrator, a best practice for tools and workflows packaging, an architecture to support the findability of and accessibility to existing models that are interoperable and reproducible, enabling fairness for processing tools and pipelines. And the visual choreography technology to describe platform-agnostic scenes, which can generate in runtime visualizations, such as the one you see on the slide. In the BlueX project, we are developing a decision support tool for the entire life cycle of blue renewable energy installations, from assessment, planning, construction, operations, and decommissioning, and for all 5 major types of blue energy. By developing immersive extended reality dashboards, we are creating multi-user tools that visualize real-time geolocated data, improving stakeholder engagement and decision-making capabilities. It is also relevant to highlight our cooperation in other initiatives, such as our Memorandum of Understanding with D2, a United Nations project, and our cooperation within Turtle, a project that is coordinated by SINTEF-OCEAN. and also our effective work on the proposal for a IEEE working group for a recommended practice in the development of digital twins of the Earth that has been approved by the Oceanic Engineering Society and that has its kick-off meeting last week. Motivated by the ocean's crucial role in climate regulation, biodiversity and human livelihoods, we seek to leverage the increasing availability of sensor data and its simulation capabilities. Key challenges include integrating diverse data sources, ensuring reliable and ethical artificial intelligence applications, and making complex ocean dynamics more comprehensible. The approach focuses on hybrid digital twins, combining multi-sensor and simulation data with AI to achieve higher predictive capabilities. Human-AI collaboration to address limitations and enhance intelligence, and extended reality tools to immerse visualization and engagement. These efforts aim to provide transparent, reliable, and actionable insights for sustainable ocean management. Human-AI symbiosis within digital twins foster collaboration between stakeholders and AI systems. We aim to build trust and encourage active participation in ocean monitoring initiatives by emphasizing transparency, personalized interactions, and ethical considerations. On our approach to hybrid digital twins includes standard-based architectures, complex simulations pipelines, and sensor and simulation data integration. These advancements enhance accuracy, reproducibility, and trustworthiness. Immersive visualization tools are key to understanding complex systems. Using extended reality, we create interactive virtual narratives that enhance decision-making and collaboration, offering an intuitive approach to ocean process dynamics. Thank you. I don't know if there are any questions. I tried to summarize these 3 lines of activity within the ocean data at INESCTEC.OCEAN. No? Okay, thank you.
Okay, thank you. Now we give the floor to robotics area. I think they are just uploading the presentation. Well, I can give you, regarding ocean data, as you saw, we gather here different competences, both in sensors, in communication, and also in data, digital twins, and how to process data. So we have actually 3 different areas at INESCTEC that are gathered in this big topic of ocean data. We considered that it was important to pass even to evaluators and the overall idea of how data can be acquired, can be set, and can be treated, instead of getting individual competences. But then I think that during the day you can talk with the persons in charge for these areas, Philippe and Rui in communications. Can you just stand up so that people from Sintef know you? Luís Coelho from optoelectronics is there. At least is the person in charge. There are more from the Photonics Center, and Marco from the data with his team. Okay, so José.
Okay, good morning. So I'll briefly present some work that INESCTEC has been doing in marine and ocean robotics and autonomous systems. So this work is led by the Center of Center of Robotics and Autonomous Systems, that we are addressing this, creating new robots for harsh and complex environments, improving both effectiveness, safety, and efficiency. It's the largest robotics group in Portugal, and working at sea. So we are around 100 researchers in field robotics, and from that, 80% is in ocean related activities. Well, the infrastructures we saw part, we see in the morning some overview of the infrastructures, and so I will skip this. So we have more than 20 different robots from air, underwater, surface, developed along the time. I will skip this, we saw it in the morning. Our background, I try to summarize the last 12 years. We have around 30 projects related to European projects related to ocean robotics. Around more than 25 national projects, and around 20 direct contracts in this activity. It has been growing constantly a long time, so a lot of this activity is more in the last 6-7 years. And we address a lot of challenges. I think tomorrow we'll discuss this, so I try to overview some of the things, background, and not projects, but because projects are too much, I group projects in a set of areas of application, and let's summarize a bit some of things we have been done in the last year. So in the ecosystem assessment, we have several projects, and one of the application was this, addressing the assessment of vulnerable marine ecosystems, where we, last year, or 2 years ago, we were asked to do some survey, because Portugal needs to provide this information to Europe, and we, using the current systems, adapt and survey several kilometers from the specific area, collect data, and provide the biologists all this data. In this line of ecosystems assessment, also integrate different sensors like DNA in different, so this was developed as specific because there was no in the market that these systems to be used by robots. We developed this in-house in collaboration with CIMAR, and integrate these both can be used standalone as an autonomous system, but also integrating robots. That is the main novelty, because we can assess and collect data in precise positions and without human intervention or less human intervention. And this also was using fish vessels to collect also data. It has been applied in several scenarios, and yeah, is a new sensing capabilities for underwater robots. Another example that we see already a bit is using cables also to observe the ocean, but in the robotics part, you are also exploring how to use this to support the use of robots, not only using this to observe, but also supporting as a docking system for charging, transmission of data of robots in order to go for resident systems, observing continuously the environment and extending that observation system, not with cables, but with additional systems, with robotic systems. And also how to use these cables also to help the navigation of the systems. We have already done a lot of work here. Another scenario of application that is now very in the news is this deep sea critical infrastructure protection. We have several projects dealing with this, and we have been doing this REPMUS exercise from the beginning. So every year at September we are in the field with the Navy doing different exercise. But one of the most important in the last 2-3 years was this critical infrastructures protection, where you use several robots. For last year, use a lander as a thread to the cable, and use other AUVs to detect the thread, map the cable, assess the state of cable. So with these at not very deep, but 800 meters deep, and probably this year they will push it a bit deeper, because typical cables are buried in the first 1,000 meters and then are laid off in seabed, so it's much more easy to damage them in that part than in the others. Another scenario of application of robotics is of course, is offshore renewables energy, where we have also several projects and also some direct contracts, and interact with several companies in that process, and using robots not only underwater and surface, but also aerial robots for inspection of assets, and typically helping in operations for maintenance, environmental monitoring, and also assessing seabed morphology changes, so understand how the skew and the moorings are, and this type of operation, but also some to need to assess with very accuracy if some structures are getting out of, so the piles are moving up, so they need to measure in global frame with high accuracy. That was a very challenging problem, and for this the Águas site is very important. Is a interesting test site, and when it comes as a technology-free zone, it'll be even easier to do different types of tests. Okay. This is one of tests with core power. We do some inspections, mainly to assess the height of the pile, but we also use some landers, some AUVs in another test in Agusadora. So typically, we can inspect, create high-resolution models, map the environment, but and provide information to later integrate those models with digital twins and other things. And the last scenario that I select was this deep sea monitoring. So where we have this Trident project where we are trying to create new technologies and also methodologies to create a new way to observe the more efficient, that also be less intrusive with the environment. For instance, try to avoid having a support vessel there for the monitoring system. And we are creating a lot of new developments and technology, and we are working also with the International Seabed Authority to try to influence the future legislation for them to put fraud contractors to have some support infrastructure for the monitoring system, in order to also to get a system that will be cost effective and can be more resident down there. So the idea is to have a set of systems observing in a resident way the phenomenon. So this is a summary. So we have already some high-trail prototypes operating and demonstrating in several environments, addressing typically we are driven by society needs, so we are always challenging and trying to address that, and with some high level of operationality at sea. But we need to go further, and for the next years the idea is to continue to improve and get a way to be able to manipulate, interact, so go from only observation to more interaction, intervention, eventual building there. And also continue this line of work of using heterogeneous robot platforms for observing, not a single robot, but a team of robots to collect all the data to feed these digital twins of ocean to provide the right data at the right time. And moving from this paradigm of having a single deployment or operation, short-time operation, to have resident robotics, go to these long-term operations and solve all the problems needed to that. So, and I probably was too brief, but any question? Tomorrow I think we'll go in details, but it was to give an overview, and but if there is any question, we can explain. Okay. Thank you.
Now, with Eduardo Silva, we'll present the maritime infrastructures. This is a new area for INESCTEC, so we won't present the competences because there are very few, but we will try to present our ambition and the step ahead. Thank you.
This is the worst part of the day. I go to talk about the topic I only know something, okay? But it's mandatory. We do the homework and the presentation. And we have a presentation. Fortunately for me, I don't do the presentation. I only go to try to present some things. Because this is new, we don't have any center work on that. We go to set up with INESCTEC.OCEAN, and we start hire people. But the people is not yet legally today to be with us. Diogo is with us here. This is our Diogo. Can raise the hand. Diogo is the guy to go to start work with us, but unfortunately for us, only go to start in April. Yeah, is hired, but and they help me to help me to write our ambition. Okay, this is the beginning. This is a draft. This is our first approach. We need to, with your help, we need to polite the things and changing things, but this is our first approach. Maybe it's a lot of ambition. Diogo have a background, and the team will go to contract, I hope, to build the background inside, but also we need to bring people from outside of the INESC to help us in marine structures, but give us some space in these thoughts. Don't believe in all my words, because it's my interpretation, not the Diogo interpretation. And if the good things are made by Diogo, the bad things I go to say is my responsibility. Okay, a lot of things we are talked before in other presentations, but the main objectives. When we start to talk with Sintef about this, SINTEF highlights that we miss one leg in our 4 legs. This is the 4 areas, and we in our developments to address properly the sea, we are missing the marine infrastructures, and we start to design a way to bring the marine infrastructures to inside of the INESC. Okay, it's not the same the other research organizations do in marine infrastructures. We are mainly coming from the area of electrical engineer, but a lot of the tangent spaces in the research, we want to work in the interface between our robots, our sensors, our energy solutions with offshore infrastructures, and this is the reason we want to build this area inside of the INESC. If you want to compare our marine, the work we go to do in our marine area with, for instance, it's very easy because our neighbor INEGI is not the same thing. Is the interface, is the part of the interface. Some things are similar, but the other things are not similar, are more in our side. Okay, the proposal of the general objectives is common part of the other areas, and of course we want, if you see in robots, if you see in projects of energy, if you see in sensors, infrastructures always are there. Okay, if you want to put a sensor inside of the infrastructure, it's better if you know the infrastructure, modeling the infrastructure. I have this internal capacity on that. And this is clearly important to join to the other scientific areas, the areas of the infrastructures. The key contributions is similar to the other teams or other areas. This is mandatory in all areas related to the sea. It's clear. It's nothing new, and we hope to have this strong impact. I go to highlight 2 or 3 things later because is in my mind. This is a quite new ideas. We need quite new ideas for that. Since the farms, the offshore farms put a lot of problems. Clearly, Bernardo brings these problems in configurations. The configurations must be important for energy, but also important for the fishermen. It's also important for the seafood, aquaculture offshore. Everything, we need to think everything together. Okay, it's not possible. The good configuration, maybe the good configuration for the farm is not a good configuration for the people from energy. This is a compromise solution between environment, fishermen, energy productions. And for that, the infrastructure solutions maybe be different. Okay? I go to anticipate, but a very good example. It's possible connect and disconnect in charge underwater. I go to the market now, I can buy a cable with, I forget the name, but I can connect 2 cables underwater now in charge. I never see, but maybe exist some companies, they bring us this. But I see I see a lot of the problems in corrosion between the metal chains, and this is very, very heavy. To take out one part of the chain, one part of the cable, one part of the anchor the price is so high. We need to find new solutions. Maybe in the future, the ends of the cables are robots and connect itself autonomously. Don't need it's not mandatory to to go there with a ROV to connect the cables, but the cables itself are robots. This is ideas for the future, and we know we want to develop these ideas inside of our project. Okay, this is we need to start to have ideas to join all areas and bring and cross the areas and do a cross fertilization in the operations. Okay, if the cabling. When do we go to the market for us? When do I go to listen and see the conference? Cabling and connectors is a very challenge topic. Anchoring, yes, is also anchoring because the sea changing all the time, and the sea in Portugal is not the sea in the North Africa or Norway. In our case, deep water anchoring is also a challenge. If you remember quickly, Portugal, after 20 miles, go deep, 1 kilometer, 2 kilometers. 60 miles, I can find 4 kilometers depth. And offshore, this is also a challenge question. Offshore aquaculture, clearly, is also a future for us. This is the key research areas in marine structures, but in our case, our research is not a pure marine structures we want to develop, but cross with the other areas. We can list a lot of the possible key areas for our research. Of course, we have now a very important area is the modeling. Since we have a test tank, we have a chance to be partner from companies, to do tests in our test tank. We need to understand the materials. We need to understand the equipment they want to test with us. We need to modeling with companies the structural equipment, and this is a long path. This is our thoughts, and we need to correct with you these thoughts. The first year in this area, we want to establish the foundations, hire people, 1 or 2 PhD people with the capacity to lead some research in this area, and start to write and see the types of the PhD students we go to engage to start to grow by inside. INESC normally grow by inside. Okay, grow students coming do a master with us, PhD with us, and stay with us working. After that, hired with a contract or our professors in the university or polytechnical school, and normally we grow from inside. It's not sometimes coming people from outside and join to us, but is not the major part of the team inside of the INESC. Start with the young age to work, and we need but in this case, we need to first coming from outside. Diogo is an example, and we need to find a strategy to grow inside. And also, we have a good thing inside because you have, since we want to have a cross-fertilization, some people maybe are with us. Some people who want to work in Marine Institute are people from energy or people from robotics or people from sensors, and want to help developing this type of research and do this research. Maybe it's not totally mandatory to think, it's not possible to find people inside to grow this scientific area. But we are open to different strategies, different ideas for create this area inside of the INESC. Okay, establish foundations is the first year, and this is the most difficult part. After that, we think we can find the projects, research projects in European calls, in national calls, to start to have ideas for that. Our first year is to do proposals, clearly. We need to do proposals because we need to bring money. Because the money of the INESCTEC.OCEAN is only a seed. This is only for build the team, build the capacity, not to do research, and we want to start to do research, and we need to start to do some research, not only with the previous funds from INESCTEC.OCEAN, but from outside. And we thought in 30 years we have conditions to start to do some work in advanced simulation and technology development. We think we start to have the first outputs after these 3 years. We can output something to have some results. And after that, since you start to have outputs, we can start to join the work with industry. Okay, we can start from beginning. If we find a company, we want to write with us a research program, support, share with us, and help us in this process, we can start before. It's not a problem. But at least in our first plans, without a lot of the boosts, we think with our internal capacity, after that we think we can have courses and integrate some industry. Okay, and if you look in the timeline, projects like Azel is more developed. Core Power is the TRL of the Core Power Rise. Other projects go to appear. We have some contacts for cabling companies who want to increase the experience in Portugal, because a lot of the cables are installed in the south, near to the Sines. They have a new solutions between Portugal, continental Portugal, and the Açores and Madeira. We think the companies, we can start to work with companies. Okay, and if you see the 5 year is the end of our internal project, and our internal project can help a lot to grow this area size. And tomorrow morning we can discuss. We can discuss now. It's open, but we can discuss if you have questions on that. Diogo is here with us, can also help on that. But I think our research project can be a backbone, not totally there, but a backbone to help us to increase our capacity in marine structures. And in the end is the final year, is the baby born in 6 years. Okay, this is not a 9 month. This is a 6 year solution, and is not a human system. This is an artificial system, and we need to do such a way it appear after 6 years appear our area, a consolidate research area in INESCTEC of the marine structures. Is the shape of this area? We don't know yet. We don't know nothing about that. We believe in our ambition, but the shape, the dimension, the type of the answers we don't have. If is the same I explained before, is not so important, but long-term vision, abstractly, okay, we want to work with us. I highlight the point 3, this is very important. INESCTEC is not, this is a research interface institute. You see both sides, research and innovation, and for that we need to strengthen our partnership with industry. Okay, Portugal, if the evolution appear in the next 6 years, we believe we can build more offshore infrastructures in Portugal. We believe the shipyards go to increase. I believe it's possible to build more ships in Portugal. I believe it's possible to appear a small industry for submarines. Okay, we don't have any. We have one small spin-off in Porto, not related to the INESCTEC, but do submarines. Maybe in 6 years we can output, or we can help appear one or two industry companies we building robots. Okay, I believe based in our solutions, or not. But if the market grow is normal. If the market grow locally, is possible to appear at least in service. If Viana do Castelo grow, the farm in Viana do Castelo grow, we need to increase the services. If we increase the capacity of the services, we can also address all world market. You don't forget, actually, the world market is only a pre-commercial world market in the energy offshore. Is a pre-commercial, but is 400 projects in the world. Maybe we also can sell research services from outside of Portugal for other markets related to the pre-commercial market. But if the market in Portugal in 10 years is a rise, because if they appear, if it is possible to start to thinking install in 2030, maybe in 2 or 3 years the production start. 35, at least in 35 the production start. If you go to the harbors, I see now Felipe and Hugo and our authority in 35 think it's possible to go to the green energy totally, and for that we need operators. For that we need people to know these new technologies and the infrastructures. Okay, then the next 10 years is very promising for the challenges, but this is our vision. In conclusions, we need to start to work. This is the conclusion. Okay. The why? Because we talk, but this time this area need to start to work, because if you see you see our experience. The people love a lot to have physical things. The semantic must be physical. Okay, also logic. The people from data, sorry. The semantic of the data normally is logic, is not physics, but the people from energy or robotics love a lot to put the hands in the materials, put the robots working, and put we hope we have a strong dream. Okay, when we started this with Bernardo some years ago with Project Coral, the idea is to do a substation in sea and start to put some industry in sea. I know the people from biology and so on are start to raise the hand. Oh, don't put nothing in sea or someone. But we need to balance the things. Some people, I don't know if we have here CMAR people. No, not yet, not today. Okay, because we need to listen to the CMAR in the impact assessments and so on. But we have a dream to put I have a dream, and I suppose Bernardo have a dream. All the team have, because participate on this, to put a substation in Aguçadora, a research substation to underwater or in surface, or coming up, down and up like turtle, do maintenance in the surface, going down to the work, robotic cables. This is also important. Robotic cage to can deal with our weather and our waves, and imagine the people to have a offshore infrastructure for aquaculture, a cage, to deal with 18 meters waves. Think on that. If it's possible, the fish can do. Okay, why not okay, we need strategies for that, and Diogo find a strategy for that, I suppose. We sink or not sink, okay? But this is very open, this topic, okay? And we have a good stone here, and we need to sculpt our stone and help INESCTEC to rise this area inside. Thank you very much. Diogo, sorry for if I do a lot of mistakes in the middle, but you forgive me, okay?
Okay, now we have our colleague from SINTEF, Beat. Thank you.
Hello, everyone. Nice to see you. Thank you so much for the very nice presentations from INESCTEC and for the tour. It was really inspiring and gave me already now a lot of ideas on what we can do together for the next coming 6 years. Some of you might think that I now am going to tell you all about the good things we are doing in the marine structures, but I will not. That will not be fair, because my colleague Nuno is the expert and he will go into that topic tomorrow. So what I want to do now is actually to give you some insights in how we at SINTEF actually build scientific excellence. So it will be a very overall presentation, and you have now 4 different presentations more into the details on projects, but I will go more into the overall mechanisms in SINTEF in order to create scientific excellence. Arne Fredheim presented SINTEF yesterday, and this is a very central figure for us at SINTEF, actually demonstrating why we are doing research, first and foremost. Our vision is to develop technology for a better society. And as you can see in this image, the competitiveness of the industry, of course, the Norwegian industry is the main objective for us, but the competitiveness is really important, but also the social benefits from our research. And what you can see on the sides in these pictures are all very important areas for Norway to do research. So this is also then important for us. What you see in the middle on the sustainability and digitalization and productivity. These are areas where we believe that we need to find solutions in order to solve the problems we have in the different applications areas. So all the research projects we are doing in SINTEF have an element of sustainability or digitalization or productivity in it. SINTEF, we divide our organization into the different institutes. Those of us here today, we represent the SINTEF Ocean side because we have the main responsibility for the research in the ocean. But we are very close colleagues with the researchers and those in the other institutes, and we'll also give you more insights in how we actually do the research together with them in order to solve the complex challenges we have. I guess INESCTEC also have experience that it's not always very easy to find a common direction when I'm doing research in different institutes. So we have developed a strategy where we are pointing at the directions, and we have also developed some strategic beliefs in what we think is really important for us to do research in the years to come. Zero emissions in value chains, artificial intelligence and digitalization, the planetary boundaries, new approaches to health and security, and transition policy are domains that actually we are trying to build new research projects in order to meet the challenges. Going more into depth in SINTEF.OCEAN. When we are going to do the research, we organize our research groups into different market-oriented departments. Arne will tell you more about the governance later today, but I wanted to put up this illustration in order to tell you how we actually group our researchers into more market-oriented departments. So each market-oriented department has a cluster of, let's say, customers or industry that we work together with in order to make sure that we actually do the research that meets their demands. And within each of these departments, we have from 4 to 6 research groups where we actually gather people that have the same background in the scientific background, and in groups that can actually build up their excellence together. So this is important for us. Not too large groups, but groups between 15 and 20 people that can actually come together and come to the daily work at SINTEF and have a community where they actually build their excellence together. And another thing important for us, I will use this one as an introduction for the topics I will go more into depth into in this presentation. First of all, we do the research for a reason. It's very important to us to have an impact. All the research we do should have an impact. And we want to also be very good at demonstrating this impact in certain ways. In the middle, you see the green boxes. These are the main topics I will go more into now. Because when we are going to succeed in scientific excellence, first of all, it's extremely important with the people. The people is doing the scientific activities, so hence the people are really, really important for us. Next, when we're doing research, we need the infrastructure. And actually, what is, I think it was mentioned yesterday as well, so what makes it really attractive to come to SINTEF and work is that we really have these research groups with 15 to 20 people together, having the common interests in some research areas, and world-leading laboratories. So what your ambitions, Eduardo, you showed us, this is really important in order to understand that in order to have the good people, you also need to have the good facilities and infrastructures. And you showed us today that you have amazing laboratories for robotics, and this attracts the good people. So this is also the strategy for SINTEF, having world-leading laboratories and attracting the good people and having nice working environments for them, having good colleagues. The third part here is the clients, also the projects. The research projects is where we actually are building the excellence. So without the research projects, it's more difficult to build the project and build the excellence. And these projects are always in cooperation with those that actually need the solution. So this is important, the industrial cooperation. A little bit into the people dimension. This is from 2023, showing the number of employees with a PhD degree at SINTEF. So this is a very clear strategy for us. We want to have a very large amount of our people need to have a PhD. And usually we develop the people within the organization from inside, as you said, Eduardo, but we also cooperate very closely together with NTNU, the university. We bring master students in our projects. We also bring the PhDs in our projects. Sometimes they get hired with us and continue working with us, but also we have researchers at SINTEF that want to take PhDs in new projects. So this is an ambition to make this number very high, and that's important for the scientific excellence. However, we should not underestimate the other groups of persons and their importance for actually making the excellence. The technical personnel, engineers, and other administrative support is really, really important in order to make the research excellence. So, because they are the ones that actually prepare the site, they actually make the test campaigns and everything work and putting up the system such that the researchers actually can do the efficient work in driving the excellence. And nationalities. This is also very important for us. We have, so 32% of SINTEF employees are from abroad. This is also important to attract the good competences from other nations and for cooperation, but also in order to have the different cultural views upon the different challenges we are upon. Also important to drive excellence. I think Arne showed you this one yesterday. This is a triple helix model that we have been, that's been very important part of the SINTEF history, where we work very closely together with the university, but also with the industry and SINTEF. We have our own role into this cooperation. This is a KPI. This is important for us in order to measure our level of scientific excellence. So we do a lot of publications, and you showed us in the earlier presentations that you also are tracking the dissemination activities. This is of course important also in order to spread our competence. This is a way of actually taking the responsibility for the development of the society and the way to share our scientific results. Okay, so that was a bit about the people dimension, and then a bit more into the infrastructure dimension. We do invest in laboratories. We are a non-profit organization, so but all the or everything that is in plus in our economy, we invest again into the infrastructure. But do of course get some help. We get some help from the government in order to do the large investments, such as the Norwegian Ocean Technology Center. And Arne also showed you yesterday the history of the development, and it goes back all the way to 1939. So this has been a very long way of building experience on how to actually give us the most efficient and well-functioning research infrastructure. And modernizing these infrastructure is also important. So we have actually continuous projects in order to actually make the laboratories well-functioning all the time. So we have all the things from what kind of people do you need in order to prepare the tests, and how to actually run them most efficient, how to share the data, how to give the results to the customers, and so on. And this will of course be also very important in this new center. I wanted to just show you one example. This is my only project example. You will get more into details into that tomorrow. But wanted to show you one relevant example from the laboratories. So this is a testing of an offshore wind turbine. And this image demonstrates, so the first image demonstrates one type of research project where we actually work very close together with our customers to test and do verification on the technologies and concepts they want to develop. But the next image is also very interesting, because this is an example of another type of project. It's actually that a project where we develop the methodology to do the tests. And this is, we are very recognized for the high level of competence into this area, where we are calling it the hybrid testing, where we are using simulations and physical instruments in the same laboratory, and developing a methodology for running the tests in itself. So this is also a very important part of how we build excellence. We build the excellence in how we are actually performing research. An overall concept sketch of what is important for us when we develop these infrastructures is that we need to actually be very clever at how we combine the simulation with the laboratory tests, as you see in the middle here, also with full-scale testing. There is some of the physical phenomena that you can test in the laboratories that you, when you are missing some information that you need to do in the full scale to do further verifications. So it's very important for us that we succeed in actually connecting these three areas: for simulation, laboratory tests, and full-scale testing. And that is why it's also an important part of the Norwegian Ocean Technology Center is the laboratory, which we call Fuel Lab. So Fuel Lab is a lot of infrastructure that we place out in the sea, along the coastline of the middle part of Norway. A lot of the infrastructure is outside our living door in Trondheimsfjorden, but we will extend it down to further down to the coast. I think this example shows excellent how we actually combine the simulation with laboratory tests and full-scale testing. Because you see on the left side, we typically start with the CFD analysis when doing the simulations to verify a concept that our customer shows us and want us to help them to improve or verify. Then we build the models and we are verifying the concepts into the laboratories, as you see on the second image. And it was interesting because yesterday there was a discussion in the panel discussion that we should actually build large pilots immediately. And so this is what we have also done in this case, because this is an example from our development in autonomous shipping. Actually, there was a Norwegian project where they built a full-size container ship, which is autonomous and fully electric. And this is what you see on this picture on the third column. However, now I come to the role of Fuel Lab, because when you build this full-size ship, that's a very large pilot, and it's expensive. So one thing is the hull and the ship in itself, but there's a lot of technologies that need to be developed in order to make this ship really autonomous and really a commercial solution with full autonomy. And that is why we have developed this test area for autonomous ships as a part of Fuel Lab, where we have different types of floating vessels, drones and technology platforms. And we are putting on different types of technologies we know we need on board the full-size vessel. So we are testing the autonomy operations in more controlled environments in the Trondheimsfjord before we are putting the technology on board the full-size ship. So this has been important for the industry partners for us to do this kind of research project together with us and using these platforms before we put them on the ship. On the completely right-hand side, you see the digital component of it all. And of course, data sharing, because we need to share actually data from all these steps in the development, all from the simulation to the laboratory tests and to the full-scale tests. We need to share between the different groups that are working on these topics, and we need to share it with our customers. So data sharing and visualization is also, of course, an important part of this infrastructure. Yeah, we will go more into details about these infrastructures later on, so I don't think I should use more time on this one. But I want to emphasize that what we see now and what was not maybe that clear before is actually the role of the digital part. Having good operational rooms where we can look at the data together, and digital twins, really important for us as well. So I'm looking forward to see how we can cooperate more into that topic. Actually connecting the things that are happening out in the sea with how to understand this data and make it a part of the decision support processes. And data. This is a topic of my interests, and clever systems in handling the data management system is really, really important. So I'm very happy that SINTEF has invested in a technology system and competence and offering services for SINTEF in order to handle data more efficiently. We have more to do, but we have started, and we are able now to share data efficiently between researchers inside our communities, but also with industry and others. So, but then again, there's a lot of things to do, and data sharing is a topic that is hot. We have realized that there's a lot of barriers for data sharing, at least also between private actors and public actors. So we have a lot of work to do, and I hope that will be a topic of that we can discuss together for the next coming years as well. Yeah. So the last ingredients to provide scientific excellence at SINTEF is the projects. We do not have a lot of support from the government. Only 8% is from the government, and 92% of our income comes from the open competitions. So the project for us is important both economically, but of course in order to have the opportunities to actually develop the scientific excellence. Some examples of the mechanisms we have in Norway in order to gather people in the research projects. This is one example. We have large centers for environmentally friendly energy research, whereof we actually are leading the one called MyTrans, and this is Trond, and we have 40 or 50 partners. It's very big. 65 partners, okay. And many of them, so a huge part of them are the industry. Where we are gathering, so this large cluster, we are going to solve really large problems for the maritime transport and reaching the 2050 goals of zero emission. Another example is, this is the same size projects in Norway. There's more programs where we are actually gathering not so many partners, but maybe 20, 30 partners in order to work on topics for 5-6 years. And SINTEF is leading many of these national programs. So these are two very important tools for us in order to do research that we know have an impact. EU has always been an important arena for SINTEF to drive the excellence. And this shows that SINTEF has actually increased our amount of EU projects significantly. We We have a huge amount of EU projects, and actually we are one of the best institutes in Norway in order to take back projects from EU. So we have long experience in how to build EU projects and how to run them and how to use them to increase excellence. That has always an impact for our Norwegian industry and for the society. The last thing I wanted to show you on the project side is that cross-disciplinarity, multidisciplinarity is considered more and more important in order to solve the complex challenges we have in the world. So that is why SINTEF also has said that, okay, we need to be very clever of how we combine the research excellence between the different institutes. Because I think all of us know that when we are putting people into boxes, there need to be some energy in order to make people work together across these boxes. So this is a mechanism that we have in SINTEF in order to make that happen, and we call it Common Corporate Initiatives. So we have between 15 to 20 different such programs running all the time, and we develop new ones when we see that it's necessary in terms of needs from the society or in our industry, where we meet up together. There are budgets for the people to meet up and actually combining the excellences in order to solve the problem together. And that's really an important part of how we work in SINTEF. Lastly, I wanted to mention also the innovation dimension of this. We do increase innovation in our industry partners every day in all the projects we are doing. And we're doing it by meeting them up in the laboratories. We are meeting up physically and showing and testing and working on projects. And this is really the most important tool we have in order to increase innovation in existing industries. However, we also see that we have a role in actually filling in the gaps in the areas where we see that the society needs more industry. So we have organized both processes and separate groups in SINTEF that has a responsibility to actually spin off companies from the results we are developing from the science we are doing. And we have also separate venture funds. And I wanted also to mention that we have set up internal innovation processes we are running, especially in SINTEF.OCEAN. We are, all the researchers need to go through a process in order to say something about the results they have achieved and say, is this interesting for innovation and for a spin-off? And then we follow the projects and hopefully some of them come out in spin-off projects. So that is also a way of creating impact from the scientific excellence we provide. I wanted to end with this subject and where we together can find a way to actually increase the competitiveness in Europe together. And I do truly believe that we have a lot of common areas where can also be complementary. So I'm really looking forward to the next coming 6 years and discussions and going more into detail and getting to know you better. And this is just a kickoff. Let's start. Thank you.
For this very inspiring and insightful talk. I really appreciate it. It's really inspiring a lot, at least for me. I would like to know, as a private company, how you manage the data flow, because policymakers and scientific community are interested a lot with the data that are also coming from the industrial and private sector. I know that in Norway there is the Ocean Hub initiative. I don't know how far you are collaborating with them, or if you have another channel. How do you manage that?
Thank you for a very good question. Actually, we realized that when we realized that the data sharing is a barrier for a lot, we need to be more clever in sharing data between the private and public actors. As a part of the Ocean Decade, we have actually established a forum in Norway consisting of both private actors and public actors and research and everyone that is interested in and truly believe in data sharing in the ocean. And this group is now consisting of around 25 different partners. We have Equinor, Kongsberg and DNV and all of them with us, but we have also the ocean institutes and meteorological institutes and those that are used to handling large amounts of data together with us. And we meet up every month in order to discuss what kind of barriers do really exist. So we have identified the barriers, like it's trust, that's something, trust and business models. So we have detected the barriers, and we have now an ambition to actually try to find some use cases where we were working on mitigating those barriers. So that is how we try to actually make data sharing happen more efficiently. And we are in the beginning, so, but hopefully this will work. And we already see actually that Equinor has promised to change the way they are sharing their environmental data, because they realized that the way they were sharing it earlier was not efficient for the researchers. So it is a matter of actually meeting up and letting each other know that I need your data and I need it in that way. So that's a journey we have started, and hopefully it will work.
Hi, thanks for your presentation. Regarding the interactions between the industry and the research and the science, so for the scale-up, I think it was really important the interactions established with the industry before. I would like to know if the industry interactions is based on projects funding by applying to grants, or there is more commitment by the industries, and if you are being able to bring different industries together in the same project, all them working together, and how you establish that.
Thank you for the question, and maybe it's a bit easy for me to under-communicate it, because this is a very natural part of the way we are doing it in Norway. We do have the Norwegian Research Council, and they have different programs where we can send in applications to run projects. And most of these programs is actually required to have industry on board. So we build consortiums consisting of different types of clusters, which have some common problems that they can solve together. And throughout the years, we have learned how to deal with the business, so the secrets, and how to deal with the different types of industrial interests in the projects. We have different contracts where they can also write in their IP, and they can have some secrets. But we also we use a lot of time in order to identify the common problems that everyone wants to solve. Trond will have a presentation later today about the business, and Trond is an expert in building good industrial consortiums. So we'll get more information about that later today. Okay, no more questions? Okay, thank you.
Before Diana brings us good news about the lunch, I suppose it's in the same place, but they go to talk and explain where is the lunch. This is we are in the alpha journey for this kickoff. A little more. In the afternoon, sorry for the people from outside, is close to INESC team and Fórum Oceano and APDL. This is now we go to start the project really in this afternoon. For people from outside, it's not possible to assist, we think this day and a half give us to all and you, I suppose, a good idea about what's going to happening in the INESCTEC.OCEAN. I want to highlight from people from outside. From stakeholder forum is a way to do the connection with industries and our partnerships. During each year, we go to promote a lot of activities related to the stakeholder forum, but also we go to organize in average. This year, the beginning is less, but we go to organize 9 courses with internal and external, with some courses we can organize with industry, some courses we can, the source of the information is possible to coming outside to INESC or to INESC to outside or with our partners. This is very important. This is points to contact also the people from outside of the INESC, and this is a way to cooperate with the industry. We go to organize 2 workshops per year, okay? And we count with all people to be with us in these workshops, and also we go to organize at least one conference per year with these scientific subjects. In Portugal or outside of the Portugal. Okay, we go to start to establish a strong cooperation with SINTEF, and we go to have a travel to Norway and vice versa. And in this moment, we go to take advantage and try to organize, we visit our partners to organize things from to outside, to keep in touch and to keep with us, align with us, the stakeholders. And again, thank you for your presence. I hope to meet at least this year in a workshop or a conference, or even in the business to see at least. I hope to find all and discuss with all and see our evolution. Don't be severe with us in the beginning if we are slow, but I hope not, but be patient with us and help us to grow this community. Thank you very much. Bye-bye.
Thank you. Some logistics information. So the lunch will be at the same place where we were yesterday. Then for the ones that will keep in the meeting, in the closed sessions, we will move room, for smaller rooms. For the ones that have computers or jackets, the room is open, so we can. It's the room next to the auditorium, so you can move there your stuff, and then you can go lunch. And we would like to invite you to take a group photo here from the stage, so that we have a record of this moment. Okay? Thank you.